Let's see how to assign pods to nodes. In Kubernetes cluster, there will be one component called scheduler. We will discuss more about this in Kubernetes architecture. Suppose using kubectl command, I want to deploy a pod onto Kubernetes cluster. I send that information to the cluster where scheduler come into picture to find the right node to schedule this pod, right? Suppose scheduler decided to put this pod on blue node. That is the job of the scheduler. Scheduler is really nice, good, brilliant. It does its job. But in some cases, we want to have little more control on where to schedule our pods. And let's take one more example here. There are three nodes with three different system types. First one is SSD, then CPU and memory. Think like this. We may deploy microservices onto this cluster where certain microservices are CPU intensive, certain memory intensive, and few they perform well on nodes which is SSD optimized. In such cases, scheduler may not know we are deploying CPU intensive workloads or memory intensive workloads. In such cases, we want to take control of scheduling. Now, suppose I am deploying. Now, for instance, we want to deploy a pod onto Kubernetes cluster. This pod requires better CPU. Now, I want to tell my scheduler, boss, please deploy this on any node which provides optimized CPU. In our example, I am showing only one node with CPU, but in real world, there could be multiple nodes with CPU optimization. So here we want to explicitly tell scheduler, please deploy it on the node which is CPU optimized. Accordingly, scheduler will deploy it on the node which is CPU optimized. This is what we are going to see in practical demonstration. To understand this further, we're gonna label nodes. While deploying a pod, in the pod specification, we're going to add extra information to tell scheduler this must go onto a specific node with specific label. Labels play a key role in this case. Let's jump into demonstration. I want to start this demonstration from clean state. There are no pods running on the cluster. Let's also check how many nodes are running for minikube. kubectl get nodes. There are 3 nodes. Perfect. The first approach is very simple one. Let me get that information from Kubernetes documentation. Let's see node name. This option inside pod specification, I can directly specify name of the node on which this pod has to be scheduled. Like this. This is coming parallel to containers, in sense under spec. After pod specification, let's give node name. Suppose I want to deploy this on minikube node. This is name of the node. It should be scheduled on this one. If I want to schedule it on the second one, then I should provide name of the second one. kubectl apply -f pyapp deployment. kubectl get pods -o void because I want to get node details where this pod is scheduled. It created 3 replicas. All 3 replicas are scheduled on minikube because we are explicitly telling it should be scheduled on Minikube. Node name option is very simple and it is direct because we are telling go and deploy it on a specific node. If node name is not found, pod gets into pending state. Let's give a wrong name, Minikube 123. Remember, there is no node with Minikube 123. Let's do kubectl apply. It is getting reconfigured. Run kubectl get pods. See, by the way, what is happening, because deployment has rolling updates concept, before deleting any of the running pods, it's trying to create a new pod. And see, it is trying to get onto Minikube 123, but this node is not available. Obviously, Kubernetes cannot schedule on Minikube 123. Probably it is going to struck here. Let me do one thing. Let me delete everything, again deploy freshly. So ultimately, yeah, everything should go off. Fine. Now do kubectl apply -f deployment file name and go and get the pods. Of course, right? There is no node with name Minikube 123, so that's why everything is under pending state. The point is, when we use node name, if there is no node with a specified name, pods will get into pending state. Let's change the name and fix the problem. Kubectl apply Yeah, 3 pods are in running state. Let's use -o wide to understand where exactly those 3 pods are scheduled. Eventually, 3 pods which were in pending state gets terminated. This is node name. Let's move on to next approach for scheduling pods onto the nodes. So from the document, let me go to the top. nodeSelector. Click on this. How nodeSelector works, we provide labels. See, in case of nodeSelector, there could be multiple nodes matching the label. But if I give node name, there is no chance for multiple nodes. It has to sit on single node. So under nodeSelector, yeah, provide nodeSelector. Under that label, it has to check for on the nodes and put it on those nodes. Let's copy this, remove node name and bring node selector. Let me change this to systype SSD or CPU. Let's deploy this. I want to delete the old deployment. Because right, I want to freshly deploy this one. kubectl apply get pods. See, these pods are also stuck in pending state. I will tell you why. Reason is simple. It is looking for nodes with label systype CPU. But there are 3 nodes, of course. No node has this label. Remember, when you do such node selector configurations in pod specification, make sure node also has these labels. So kubectl label nodes, name of the node, systype equals CPU. Out of 3 nodes, one node has this label. And see this one. When I run kubectl get pods, all pods are in running state. Previously, they were in a pending state because there was no matching node with a specified label. Now it found a node with specified label. It is running on that node. We are done with 2 approaches. Let's see the last and final approach. Let's go back to the list of approaches. Go to the top of the page. It is affinity and anti-affinity. I am going to show only one concept under this, that is node affinity. This approach, right, it is almost similar to nodeSelector. It works based on labels, but it has little more flexibility. In case of nodeSelector, when I give a label, it will go and find nodes with that label. If it is found, it gets deployed. If it is not found, it will get into pending state. But in node affinity, the flexibility we have is we can say mandatory or optional. So when you say required, see these 2 options we can configure. Required during scheduling. Required means mandatory. If nodes not found with specified label, pods cannot be scheduled. That should be in pending state. The second option, preferred during scheduling. In this case, preferred means optional. If there are nodes with matching label, deploy it. Otherwise, still okay, put it on any random node. The second part, right, ignore during execution. After a pod is scheduled onto the node, if someone changes the label, ignore it. Don't again bring it back to pending state. That is the meaning of ignore during execution. Let's copy this. Let's use it here. Key systype we can specify multiple values for a given key. So now, according to node affinity configuration, required at the time of scheduling, it is mandatory. If no node found with a specified labels, do not schedule. And ignore during execution means once it is scheduled, if someone is changing labels on the node, please don't care, leave it, let the pod keep running on that machine. Let's deploy this. I want to delete existing deployment and create it freshly. So kubectl apply -f deployment file. And see that everything getting onto minikube because minikube node has the label systype CPU. That's all about scheduling.